Grade 10, Unit 12 seminar on word problems, applications of the different the different types of quadratic equations that you have learned up until now. Now, the first slide says applications for completing the square. That doesn't mean that in the entire Unit 12 guide you're going to be completing the square for every question. What that does mean is the first problem is an example where you have to complete the square. So the problem reads, tickets are sold at a fundraiser. Last year they sold tickets at $11 each and 400 people attended. They are planning to increase the price, and a survey indicates for every $1 increase in price, sales will decrease by 20 people. Now this is the type of problem you're not just going to encounter in grade 10. In the grade 11 completing the square unit, they do the exact same problem. So it's challenging because there's a lot of information, but if you know how to set up the question properly, you'll be able to do well every time you encounter this question. So you'll encounter it in grade 11, you'll encounter it in grade 12 because it's a maximization problem. Now, the bottom of the problem reads, what ticket price would maximize the revenue? Whenever you see the word maximize or minimize, when they're asking you for profit or something that maximizes the situation or minimizes the situation, you always use the completing the square method. That is the only time you use the completing the square method, is when you see that word maximum or minimum, or maximize and minimize, because completing the square helps us find the vertex, which is either the maximum point and the minimum point. And this entire unit is taking quadratic equations and linking it to real-world situations. If you had a company, it's very common for a corporation to ask their financial planners, their financial people, to tell us what is our optimal, our maximum profit that we can reach, or maximum sales that we're trying to reach before our graph kind of goes down and we start losing money. So they're always looking for their maximum or minimum profit margin. This is a problem that you will encounter if you go into business or finance or anything like that. Now, the key to this question is the little note that I've placed over here. In order to set up the equation, we have to come up with a quadratic equation. And because we're looking for maximum revenue, you have to know what revenue is, how we can calculate revenue. So our starting point is finding the number of tickets sold and multiplying that by the cost per ticket. So that's how we're going to set up our quadratic equation. Number of tickets sold times the cost per ticket. And we do have to start with these two binomials, this type of situation. So I'm going to say revenue is going to be equal to one binomial times another binomial. But the problem that students run into is, now what? How do I set up these binomials? So I'm going to give you a trick that I never want you to forget. The very first terms in each of my binomials, very first terms, their starting point, is going to be what happened last year. What happened last year? So if we go back to the problem, it says last year they sold tickets at $11 and 4 people attended. So $11, 400 people attended. So if this first binomial represents the number of tickets sold, so that's my sales, if 400 people attended this event, then that's going to be the number of tickets sold, 400. This binomial represents the cost per ticket. And I know that last year the tickets were sold at $11, so I'm going to put in the number 11. That's my starting point. The second part of each binomial is going to represent what is happening or what is projected to happen this year. So if we go back, this year, for every $1 increase in price, sales will decrease by 20 people. So to translate that into algebra, my sales are going to decrease, so negative 20, for every ticket sold. So negative 20 times X. The X represents for every ticket sold. And that will happen because we plan on increasing, so positive, $1, increasing the price per ticket by $1 for every ticket sold. So X doesn't represent the sales or the cost per ticket. It is a variable, or it's a number that's going to be used to help us calculate. This binomial represents sales. This binomial represents the cost per ticket. Once we complete the square and find the maximum value for X, because the problem is asking us for the ticket price that would maximize the revenue, that means I'm going to be substituting X back into this binomial later on in order to tell me exactly what my ticket price is going to be, okay, in order to reach my maximum revenue. So I have two binomials. It makes sense to come up with a quadratic equation. I have to use FOIL, okay, so we're going to FOIL these binomials. R is equal to 4,400 minus 220x plus 400x minus 20x squared. Now I have to rearrange and put the terms in order of a quadratic equation. So my negative 20x squared is going to come first, negative 20x squared, plus 180x plus 4,400. Now, because we are using the completing the square method, I have to go back to what I learned in Unit 11, which means we have to separate our equation into Team A and Team B. And what is wrong with the equation? What do I have to factor out of Team A, the first two terms? What do I have to factor out? Does anyone know? Want to see participation in the seminar? Gabby, what do you think? What's in front of the X? Yes, this negative 20 can't be there. For completing the square method, if you've done Unit 11, you know that whatever term, it doesn't disappear, but we have to factor it out in order to complete the square. So what I'm going to do is divide both of my terms in Team A by negative 20 so that the negative 20 goes on the outside, and then I'm left with x squared minus 9x plus 4,400. Very important to note that the 4,400 does not get affected by this whole dividing by negative 20 because it only happens to my terms on Team A. Okay, now that I have my proper equation, my proper A, B, and C term, I can figure out the next step for completing the square. I have to solve for my B divided by 2 term and my B divided by 2 squared. So I now know that my B value is negative 9. So negative 9 divided by 2. We can, let's keep this to a decimal, negative 4.5. If my B divided by 2 value is negative 4.5, then negative 4.5 squared is going to give me positive 20.25. I'm going to use this information in order to complete completing the square process, in order to get my equation into standard form. So, let's continue up here. I have negative 20 x squared minus 9x. That's my Team A. And I have a positive 4,400 in my Team B. Because my B over 2 squared value was 20.25, I'm going to take that 20.25